Okay, hello everyone. Good morning. This project, Airborne Software Reviews, is a research project when I was in MIT studying the airworthiness master degree. It is pre-recorded, so let me continue.
Excuse me.
Hello, can you
Yes.
hear the voice?
Yeah, the voice is not connected. We cannot hear.
Oh, you cannot hear it. Okay. Okay. It because it is pre-recorded. So now I try to explain it by myself.
Okay, whatever suits you. Go ahead.
Yeah. I have two supervisors. Nick Connolly is a professor of MIT, and Samuel Edwards is a software specialist from Australia, DASA. It's a certification authority. And can you hear it clearly?
Sorry?
Oh, okay. Nowadays, we know almost every aircraft system contains software that include a flight control system, hydraulic system, landing gear system. Airborne software plays a key role in the safety of aircraft, and software reviews can ensure compliance with the regulatory requirements and ensure aircraft safety. Because airborne software, it have a special feature. It is intangible, it is high integrated, and it is pretty complex. It cannot be exhaustively tested, and it's safety related. Some software, for example, the software in a flight control system, the abnormal behavior can lead to a catastrophic failure condition of the aircraft. So it's very important. That's my research topic. My research main question is, what are the specific what are the ideal technology coverage and airborne software review strategy for an airworthiness authority? Software is it's developed. Airborne software, it's safety related. It's developing process involved different many software technologies and safety technologies, requirements technologies. But what are they? We should identify all the technical focus points. So when the certification authority performs software reviews, they can focus the technical points, not only process review. So it has the three sub-questions. One is, what are airborne software regulatory requirements? It is a certification basis. And what technologies should be identified and focused on during software reviews? What is the sampling strategy of software reviews? Because we have so many software data, we cannot do a 100% review. So we need to make a sampling strategy for the review. If we follow this strategy, we can find the problems or unsafety issues. Why I select this topic? Because it is if we can remember the MAX 737 MAX the accident from October 2018 and March 2019, the two airlines, Lion Air and APR airline have a total of 346 deaths, which was directly related to the design of markers and its flight control law software. And the committee published more than 500 pages report last year. The software is mentioned many times. Software review could find the problem if Boeing, BDCU, and the FAA can perform the sufficient software review. They could find the problem, although it's also a problem of Boeing's safety management system. They have different, they failed in different layers of defense within Boeing, but the software review could help them to find the problem. There are three objectives of this research. First one, I analyzed and captured airborne software regulatory requirements and policies to justify the certification basis and means of compliance. Object 2, identifying the range of airborne software technical focus points based on the typical advanced based on DO-178C. It is a standard published by RTCA nowadays. It is recommended by different certification authorities all over the world, including FAA, EASA, CAC. We also use this standard as a means of compliance for airborne software. Objective 3, we should developing the software review and sampling strategy that we can support a national airworthiness authority to do a sufficient effective software review by taking into account the frequency and depth of the reviews. Yeah, I performed the literature review from 4 aspects: regulatory requirements, and as software review policy, software review related technology, and software review and sampling strategies. I reviewed more than 700 of literatures on this project. I have a stamp. I use the stamp-by-stamp methodology. Step 1 is analyze the airborne software certification basis and the means of compliance. It includes the transferability analysis, identify the general certification base of airborne software, and do a comparative analysis of FAA, EASA, CASA, and CAC software policies. And then I identified the process-based technical focuses. It both include quantitative analysis and qualitative analysis. Step 3, I developed the software SOI review strategy. I researched the level of involvement criteria based on FAA and EASA's research, and developed a set of software review strategies, combining software technical concerns and sampling strategies by an approach, innovative approach. And I make an analysis of 2C metric. It's a technology objective coverage metric. And step 4, I provided the recommendations and conclusions for the future improvement and achieving of this research. I do the analysis from these 3 aspects: regulatory requirements, technology review strategy. This is the also the analysis approaches I used in different aspects. I use the comparative analysis of airborne software regulatory requirements and quantitative analysis of DO-178C software life cycle process and objectives. I also analyze of technical focuses of DO-178C process in a mixed approach. And then a combination approach, both qualitative and quantitative analysis of software review and sampling strategy. This is the analysis of regulatory requirements. This is the ICAO Index 8. It is about large airplane, helicopters, small airplane engines. It is the regulatory requirements from ICAO. Then each country, they developed the Part 21, Part 23, 25, 27, 29, 33. And from this regulatory, it is have a traceability to the ICAO. Software from this regulatory, I captured the software related requirements. It's software implemented the intended functions, the developing process to be maintained at acceptable safety level, its safety requirements and installation requirements, the right software to be installed in the right equipment of the aircraft, with the regulatory, they required the conformity inspection. So I get a conclusion that software certification basis should be Part 25, 3301, 3309, which they also have sub-items. So now the question rests how to demonstrate the software comply with this certification basis. So the software cannot be full tested. Airborne software cannot be full tested. Here I give an example. If the number of fully tested cases, if n equal 53, and it would be 9,007 trillion combinations, that the software developer need to 2 million years to complete the test. So it's impossible. That's why DO-178C is widely recognized as means of compliance by the certification authority. I made a comparison of software review policies among the main certification authorities. It's America, USA, FAA, and Europe, EASA, Australia, CASA, and China, CAAC. I compare their requirements in software reviews. And all of these authorities, they use DO-178C based SOI review strategy. Then I analyze the DO-178C process and objectives. This is the airborne software developing process of DO-178C. They have mainly it have 6 parts. The first part is developing the software planning documents. It includes the certification plan, software development plan, software verification plan, configuration management plan, and the quality assurance plan, and also 3 standards: the requirements standard, design standard, and the coding standard. And then the second part is software developing process. It should follow the planning process, the plans approved in the planning process. It also have a 4 supporting process, that is a verification process, configuration management, quality assurance, and the certification liaison process. These 4 supporting process, they are integral process. So each software data, they should have traceability from the higher level requirements. I analyzed of the DO-178C process contribute to identify the technical focuses. I try to identify the technical focuses from each process. Finally, I recognize the 82 technologies which can assist in developing an effective software review strategy. For example, it's the software review and analysis. This sub-process belong to software verification process. So technical focus points and elements, I identify this from DO-178C, and from each DO-178C chapter, I recognize these technologies. So totally, I identified 82 technologies. Then I make a metric for each process. It's technology coverage. I make this coverage metric and analyze each process, the distribution of each process. So planning process have 25 technology focus point. Verification process have 25. So this is the maximum technology coverage. Then I based on the technology, I analyze the level of involvement for each SOI review. Mainly based on these factors, the software category, software design assurance level, project characteristics, new technology or unusual design features, alternative methods, applicants design assurance system, the delegator and organization delegation involvement. I add this is the new research studied factors. I add this based on EASA and FAA's LI criteria. I developed the objective or oriented risk-based SOI review strategy. This is the whole review process. Safety assessment requirements, then study quality assurance, system requirements, develop plans, develop traceability, implement configuration management, SOI1. Then it's the developing process, the high-level requirements, low-level requirements, SOI2, conformity review, SOI3, and SOI4. This is the final process of SOI review strategy. I also make a top-down and bottom-up sampling strategy. So the summarize the SOI strategy, SOI1 planning review, assess the interface with the system, assess all applicable objective meeting plan of DO-178C. Additional consideration, SOI2 development review, sampling review strategy. I review the select the system from system requirements, then review the high-level requirements, the architecture, software design description, and the target computer. Also, in this process, I will focus if they use the model-based development. SOI3, it's a verification review, sampling review strategy, review test case, procedure, and the requirements coverage, code structure coverage, and also it have additional verification for the level A software. SOI4 is a final review to approve the software. SOI review sampling strategy. I developed this sampling strategy. It can contribute to a successful and effective software review, so as to ensure aircraft safety from software perspective, especially for critical software. It's a function-based, catastrophic and hazardous failure conditions, random sampling, and new technology, flight test functions, additional consideration. let's review the 737 MAX case study again. This is from the Boeing's website. They have makers only active in manual flight mode. In auto flight mode, it should be deactivated. So when do the certification reviews, additional consideration in plan for in the certification plan, development plan, verification plan, they should caution this technical point, deactivated code. So there are several chances to find the market system software defects if using the review and sampling strategy in this study. In the planning process, they should identify the markers deactivate code issue. For deactivate code, it should have a protection mechanism, develop a protection mechanism to ensure that the software can be unintended activated in a specific environment. SOI2 development review using the sampling strategy to pick threads in the second chance to find market software is active depending on single AOA sensor. The protection mechanism interrupt handling issues. And SOI3 deactivated code should be reviewed to ensure it cannot be intentionally active with a protection mechanism, and each model should be tested and verified. That is the third chance to find the problem. And the final certification review, there is also additional consideration in software accomplishment summary, which makes the first chance to find the deactivated code is unsafe. I develop a technology objective coverage metric provided the technology and objective that should be questioned and assessed during each SOI review. It can make the software review in sufficient depth. So I have this analyze technology and objective. I get these four results. Result one, obtain the specific airworthiness closures and compliance methods applicable to airborne software, identified 82 technologies and developed the process technology coverage metric based on DO-178C. I also identified the software LOI review affected factors, which is helpful to plan the involvement of NAA. Also developed a comprehensive software review and sampling strategy, which can assist an effective software review to ensure aircraft safety. Finally, I have 3 recommendations. The first one, software reviewer of the Airworthiness Authority should be familiar with the software technologies that may be used in software development processes, especially the application of new technologies and new methods. For example, the model-based development and the tool qualification and so on. Recommendation 2. Software reviewers to have an understanding of system development process. They should communicate it sufficiently with the system engineers and the safety assessment process. And it is the integrated modular avionics architecture to cross-check information with the system certification officers. And the last recommendation is, I hope FAA and EASA jointly publish the DO-178C based software review guidance, including review strategies and sampling strategies for each SOI. Now we still do not have a detailed review handbook from the certification authority. Finally, let me have a conclusion of this study. I studied on the ideal technology coverage and airborne software sampling strategy. It is of great significance to the airworthiness authorities. Second, the study captured the specific regulatory requirements of software. identified 82 technologies and developed the software review and sampling strategy. 3, the main contribution of this study is that it can help national airworthiness authorities to maintain software expertise and formulate more effective software review procedures and guidance documents so as to conduct in-depth software review to ensure aircraft safety. The fourth one, limitations of this study is that software review and sampling strategy in this study is based on level A software. It is the severe safety related software, and there is no chance to do interviews with the CASA certification engineers. CASA is Australia certification authority. And 5, suggested that a future study to explore the applicable technical focuses and SOI review strategies for different design assurance levels of airborne software based on each objective of DO-178C. And the last one, the ultimate goal is achieved by developing the technology objective coverage metric to guide the NAA to conduct effective software reviews. Yeah, so that's all of my report. Thank you very much for your time.